All right, let's start. My name is Anru Zhang, and I'm Associate Professor of Department of Biostatistics, Bioinformatics, and the Department of Computer Science at Duke University. I also serve as Associate Chair for Research at the Department of Biostatistics and Bioinformatics at the School of Medicine at Duke University. I previously taught as Assistant Professor at the Department of Statistics at the University of Wisconsin-Madison. I got my PhD in 2015 from University of Pennsylvania and a bachelor's degree at the Peking University in 2010. So you might wonder, why am I here? I was really fortunate to be selected as one member of the 2024 class of the COPSS Emerging Leadership Academy. So as a little background, COPSS is short for Committee of Presidents of Statistical Societies. The COPSS is made up of various statistical societies, including American Statistical Association, ASA, the Eastern North American Region International Biometric Society, which we often call it as ENAR, so Western North American Region International Biometric Society, we often call it as the WINAR, as well as the Institute of Mathematical Statistics, IMS, Statistical Society of Canada, SSC, and COPSS is also have a lot of friendly societies, including Bernoulli, CWS, IBS, ICSA, IISA, ISBA, ISI, KISS, NISS, RSS, as well as SSA. So COPSS, gives many awards each year, including the COPSS Leadership Academy, and recently renamed to the COPSS Emerging Leader Award. The purpose of this award is to recognize early career statistical scientists who show evidence of and potential for leadership. It also provides a mechanism for us to share our vision and leadership with the field. So from this webinar series, which is co-organized by COPSS, as well as our wonderful partners as NISS, National Institute of Statistical Sciences, and we want to provide the opportunity to feature leaders in our discipline and invite them to tell their stories and share their insights. So this webinar will include, say, the storytelling and as well as the Q&A sessions afterwards. And the series can be found as this website link, and you can check. All right, so today's topic is about the leadership in statistics and the societal impact. So today, we would like to highlight the role of statistics, not just as a technical tool, but as a powerful thrust to dealing with real-world challenges. We want to explore how advanced the methodology can address the urgent societal challenges, and how research translates into policy and the public benefit, and how collaboration across different disciplines can lead to greater impact. And we are very fortunate to have two esteemed colleagues who are great at both, say, developing and making, say, bigger impact. And they will share their experience and insight on today's topic. So our first panelist is Sir Bernard Silverman, PhD. He's the pioneering statistician in the field of computational statistics with wide-ranging contributions spanning theory, methodology, and real-world applications. He has engaged in extensive collaborations, working with experts in physics, life, and social sciences, as well as making big impact in both industry and the government. Sir Bernard is a leader of our society. He was the president of IMS. He won the COPSS President's Award in 1991. He is a fellow of the Royal Society as well as the Academy of the Social Sciences. He won 2 Guy medals, and silver and bronze. He was he received his knighthood in 2018. Yeah, so Bernard actually, his journey in mathematical statistics actually began very early. He earns a gold medal at the International Mathematical Olympiad, and actually he co-designed the first pocket programmable calculator, which shows that his spirits and passion about the computation, in computation. He held the senior academic and the leadership roles at various universities, including the Bath, Bristol, and Oxford. From 2010 to 2017, he served as the chief scientific advisor to the UK House Office, providing critical scientific guidance on policy, operations, and research strategies at the highest level of government of UK. His advisory roles extend to key UK government bodies, including shaping the Office of the National Statistical Census Strategy, chairing the Geospatial Commission, and advising the Technology Advisory Panel for investigatory powers, ensuring science informs decision of national significance. So our second distinguished panelist is Professor Peterson. Professor Peterson is a professor of biostatistics at the University of Michigan, Ann Arbor. He previously taught at the Southwest Jalton University, York University, and the University of Waterloo. He published more than 230 papers and mentored 26 PhD students and 6 postdocs, many of whom are out now in the academic position in prestigious institutions, major tech companies, and startups. He also has done groundbreaking research in various fields like data integration, distributed inference, high-dimensional data, longitudinal and mediation analysis, spatial temporal modeling. He collaborated broadly in medicine and public health domain, including kidney donation system, nutrition, environment, chronic and infectious disease agent, nephrology. He also authored the book Correlated Data Analysis, Modeling, Analytics, and Applications, which has a big impact in the society. He also served on various national and societal and university level community that leads to a greater impact. All right, so that's the introduction. So the structure of today's event will be as follows. Each of the 2 panelists will have about 10 to 15 minutes to talk about their journeys. Then I have some prepared questions. And finally, we'll open the floor and open up to the audience to ask questions. So next up, I would like to have Professor Bernard Silverman to talk about their academic journey. Sir Bernard, do you want to go ahead?
Can you hear me okay?
Yes.
That's excellent, great. So I don't know how many people are here, but welcome and thank you all for giving up your time. It's a great pleasure to be involved in this. You've already given my talk for me because you have explained all the things as I did, which no wonder I'm tired. Let me try and give an idea of how this happened. I suppose I'm a kind of restless person. I like doing lots of different things simultaneously. And even if you look at my PhD thesis, you'll see that it has more than one topic inside it. So I spent some of my time working on density estimation, things like that, and some of my time working on some probability theory stuff. And those eventually came together in my PhD. And furthermore, I was a PhD student for about 1.5 years, and then I was offered a job, which was this job designing calculators. Someone rang me up and said, "Oh, well, would you like to come and work for us and program chips for calculators?" Anyone that you'll be very amused because the chip, you measured the memory in bytes, not even megabytes, kilobytes, something like that. It was a number of bytes. I can't remember exactly how many. And you had to cram in to a very small space the program to actually run everything. And so it was very interesting for me writing that. I was the first person in the Oxford Maths department to use a computer. And so I'm very amused when people suggest that older people don't know anything about computers, because I've been using them for more than 50 years. And they are, of course, nothing like what they used to be. Now, what my mathematical journey is interesting, I think, because I started off it, as you see, as a sort of, I was quite good at mathematics at school, and I did a lot of pure maths when I was a student originally, but I realized two things. First of all, I don't think I was good enough at pure maths to really be to succeed. You have to be, it's like being a musician. To be a professional musician, you have to be really fantastic. Otherwise, it's not a very good line. So I sensed that I was never going to be that good a mathematician. But the other thing was, I was always, it suggests here that I'm not speaking English, that I am speaking English, so we'll do that. I wanted to do something which was about other things. I was keen that I should put my mathematics to a use which had a wider impact. And statistics was fantastic from this point of view, because it both enabled you to develop mathematically and also to do things that had links to other issues and other topics which had wider benefits and implications. Actually, pure maths does as well, so I'm being a bit unfair to pure mathematics, but it didn't really feel like it to me at the time. So I think throughout my statistical career, starting from when I was doing my PhD, I always wanted to find areas where understanding the mathematics better and implementing everything on the computer together itself fed into the problem in hand, and also that the applied problem, not only could you approach solving it itself, but what you did would then be of wider applicability. And so if I look back to the beginning, for example, I worked a bit with people in medical science on cot death, crib death, what we call in America, sudden infant death syndrome, where there were measurements and we needed to figure out whether they came from one population or two or three. And I worked on a way of looking at multimodality and density estimation and so on, which was a way of approaching that problem. So that was an example. And then there was another example long ago in material science, where you had fibers and you needed to discover how clustered they were, and that led you to think about spatial point processes, and so on and so on. I think you have to be ready to get yourself known. I mean, I think it's a matter of being trusted by the people you're working with, and that means meeting them where they are, and also trying to make any difficult concepts simple. That's a very important point. If I fast forward in my life, I know another 5 minutes, I also quite like running things and so on. And I ended up as a head of a university department and later on of a college. But I think when I got to the age of about 50, I sort of had run out of steam with being an ordinary academic. I don't think there's anything wrong with it, but for me, I was restless. And so I went into a more administrative kind of role. And then after a while, I thought the best thing was actually not to work in academia at all, but to work with the government. Now, I'd been involved in government advice for a long time before that. So there were lots of consulting jobs and so on that I'd done in defence and in other areas. But what came along was the possibility of becoming what's called a chief scientific advisor in the Home Office, which is like the nearest equivalent in the US is the Department of Homeland Security. It's responsible for crime, for immigration policy, and for various aspects of national security. And it was absolutely fascinating because you ended up being inside this government department as a senior civil servant, but at the same time, your job was always to look for the scientific issue that would be the key to the problem they were looking at. And there were lots of these. And the one that actually had the biggest influence on me was on modern slavery, human trafficking, where our government, at the time, the minister was Theresa May, who went on to become the Prime Minister. She was very keen on having a single law against modern slavery, as we call it. It's not that it was legal before, but bringing it together in a single offence with a very serious potential punishment was a way of really, hopefully, doing something about this terrible problem. And they came to me and they said, we need to figure out how many victims there are. And there was no way of knowing, because most it's a hidden crime, you don't know how it happens or anything. And so what happened was I realized the government had some data that could be used for this purpose. It's quite a long story as to explain how you do it, but we had to develop new methodology to do it, and we had to do it very quickly. And what interested me was how excited the politicians were, because at last they had at least some basis for saying how big this problem was. I mean, I think we were a bit conservative, pessimistic about our numbers, but they were really very excited about it. And the scientific advice was front and center of the government's process to bring this into law. I've only got about 2 minutes left, but I will just say that that's probably the thing I've done that has had the most impact. There are lots of other things as well, but that's the, and how did it happen? It more or less happened by accident. It happened because I was in the right place, but also because when I was asked to do it, I spotted the opportunity. And so you can't force yourself into a position where you will have an influence on policy or things like that. But you can be ready if the opportunity arises. And it's by keeping an open mind, by having a broad understanding of the subject, and also by being the sort of person who's able to convince the people that don't understand anything that you have something to say that can be useful and that you can explain it to them in good, simple terms. I retired from full-time work about 5, 6, more, nearly 8 years ago now, 2017. But since then, I've kept very busy. I still sit on various different government advisory committees. And even today, I was talking about the way that we're going to run our next census. And there's already all sorts of questions about modernizing the way in which we collect data for the census. And so the next UK census in English and Wales census in 2031 won't necessarily look the same as they have in the past, because of building in all the different sources of data, administrative data, and so on and so on. And it's a very exciting part of that journey to be advising on all that. So I look forward very much, first of all, to Peter's talk, and secondly, to answer any questions that you may have. Thank you very much indeed. Thank you.
Thank you very much, Sir Bernard, for sharing us your stories. Sir Bernard just mentioned about the combating the human trafficking. I just want to point out that 2 years ago, there's a webinar also held by NISS and talking about the statistical method for combating the human trafficking. Actually, it's available online, so maybe I can put it for the audience. If you're interested, you can take a look.
I should also say that I've got a web page that you can look up, which has all sorts of things about what I do and have done on it. So I'll put that in the chat when I was interested.
Okay, that's wonderful. Thank you. All right, so let's move on to our next panelist, Dr. Peter Song.
Thank you, Anru. Can I share my screen? I
Yeah.
did prepare a few slides, so thanks for the invitation, and it's a great honor to be involved in this new event, which I think is very important, exciting event, and also is great honor for me to team up with Sir Professor Bernard Silverman to be in this panel or this webinar. And I do have a book written by Sir Bernard that someday maybe I come to your office to get your signature. And so I think that Bernard talked about retirement. I think that is also a buzzword that sort of rings my mind sometimes. And I've been in this, profession over 40 years. I'm thinking, this word retirement all the time. And so that's why I want to talk a little bit about my journey. But I think that what would the most important things I would think about for the period of 40 years in statistics. And I think that I have a lot of these abundant positive correlates in my career. Like, I think that's something I probably would talk a little bit. So I think everybody has this own journey, right? So starting somewhere, and somehow some people were determined to come to this discipline statistics. Some are coming to this discipline randomly. I was one of the sort of the students randomly picked up by university admission programs, and as by chance I entered the discipline of statistics. I enjoy so much, and overall I think in the past 40 years, I think this scholarly a kind of lonely journey, because in this discipline we emphasize quite a bit of independence. So we have to come up with our independent research programs, independent sort of the collaboration, independence of many things. But this doesn't really exclude, building up, associations with other people. I really like the insight from Warren Buffett. He said that most important things in his life is this what people that are going to be associated with him. So I feel the same thing. Like over 40 years, I feel that we come from different families, we come from different culture, different backgrounds, but we have a lot of the positive associates in our career, like our teachers, our advisors, our colleagues, our students, or collaborators, friends. Of course, some of the people that who are associated with life are out of your own choice, right? They come and but some are really that you can build up, right? If you want to be a future leader, okay, you have to deal with the promotion package for your junior faculty in the department, that who you are going to invite someone to write letters that can really reflect the evaluation of the case. And if you want to solve a problem, that problem is so difficult out of your skill sort of comfort zone, who you want invite to join your project and help you to work together to solve problems. So I think building up this sort of association with people who are going to make a positive impact in your career, I think this is something that I feel like when I look at this retrospectively, I feel this is very important things that we need to really constantly think about and build up on. So I sort of reflect a little bit on my education. I think that I went to University of British Columbia for my PhD degree. And I met Ben Jorgensen. He's a Danish statistician as a professor in the Department of Statistics at the UBC. And uh, so he's famous for his theory of dispersion model. And I read his paper published in 1987. It's a single author GSB discussion paper. I was totally attracted by the idea of this dispersion model. Essentially, it's a classical model that basically talk about the error distribution for generalized linear models. I think that's very fascinating idea, a formulation how, this error distributions can be, formulated in the different ways to explain, error distribution for generalized linear models. That was a very sort of important moment for me to to decide to work with him for my dissertation research, because I see the creativity in his work in that discussion paper. And I think this is very nice, sort of the starting point of my career, because I decided to choose certain direction of my research and looking at some of the regression method that go beyond, the traditional linear regression model, right? So, and because he was his research was funded by a grant to look at the a study of impact of air pollution on respiratory disease using EHR data. I think that was quite an interesting topic that I worked the application through my dissertation. So during that period of time, I was very lucky to learn a lot from Harry Ju on copulas. So you can say that at the end, I do a lot of the, this research that sort of integrate this dispersion models and copulas and through my career. So in terms of my trajectory of a career, I think that I graduated in 1996. I moved to Toronto to work at York University. And of course, that Toronto is famous for good restaurants. That's the important factor to attract collaborators there. So we have a lot of visitors coming from different places. Then I had good exposure with a lot of top researchers during that period of time. And one of the things I like to mention is that in 1996, at a conference, I met Annie Chu, right? She was an assistant professor at Oregon State University at that time. And then we're both interested in longitudinal data analysis and then, good restaurants in Toronto. And so we start to build up a very good collaboration. And then so it becomes a really long-term sort of collaborative relationship with her. And I think that I learned a lot from her. And then at the same time, I built up my own career of research from that. So 2004, I moved to Department of Statistics, the University of Waterloo, where I, have a little bit more interaction with, the other researchers in the statistics, particularly in the optimization and, applied mathematics. I feel that part is quite important for me to sort of extend my sort of the skills from the traditional regression analysis, the longitudinal data to something more towards optimization. So in 2007, I was sort of promoted to full professor in statistics at University of Waterloo. At that time, I was thinking that how can I show that I'm eligible or qualified to be promoted as a full professor. I thought that it's important to demonstrate my comprehensive understanding of the field of longitudinal data. So I decided to write a book by myself to really sort of demonstrate I have a comprehensive understanding. I know this field well, and so on and so forth. That's sort of the work I did and published in 2007. So after I promoted full professor and Wardo, I was thinking, well, what is going to be my next step of career? And so I really feel that the doing more applied work is important, and that's why I decided to move to University of Michigan Biostatistics 2008. So, there are a lot of challenges after I moved to University of Michigan Biostatistics because this is the place where we do a lot of applications. And so now you can see that I work on a lot of the applications and statistical method. I sort of juggling this two side all the time and working on a lot of real data applications, talk to medical doctors, and in the same time thinking about what are new statistical methods are needed and how we're going to integrate these two fields and statistical methodology research and apply sciences. So I've been working on. I enjoy so much being juggling this two side and trying to communicate this two side, hopefully to make some impact work. Okay, but I over time I think it's very important to have good balance between work and life. So I mean, as a faculty member, I have the privilege to travel many places, meet new people, and talk to researchers from different continents, and I enjoy working with my students. I like classical music. I occasionally play violin. I learned when I was a child, and I like singing. I like play badminton. I do regular planking, 12 minutes, and so on. And during the pandemic, I started to learn acrylic painting, and so I think that balancing life and work is extremely important because our whole journey is marathon. It takes a lot of effort, a lot of concentration, lot of energy, and sometimes you need to know how to relax, how to find other sort of the ways to relax and ideas and uh, important valuable thoughts from other fields. So I think that's extremely important to be in academic, involving heavily in the research. Okay, that's all I want to say. Thank you so much.
Thank you very much, Peter, for sharing your story. I just have a quick question. In your last slide, I saw a painting. Was that painting by you?
Yes, I did. Yeah.
Oh.
2023. Yeah.
Oh, that's impressive. Well, so maybe next, let's move on to the moderator Q&A session. For the audience, if you have questions for these two panelists, please put them to the Q&A button at the bottom of the Zoom. Meanwhile, I have some prepared questions for you too. I want to ask first, can you share a moment when you realize that your work has influencing decision of societal impact, perhaps in public health or government and so on and so forth? Can you say more? Can you say more about this?
You asked.
Yeah, sorry,
So-
Peter, you go ahead.
Yeah, I think that one thing I think that I will rank it high as impact is the kidney pair donation program I involved at University of Michigan. It's essentially a optimization organ allocation program, particularly for kidney organ allocation. You know that the optimizing the organ allocation to reduce the risk of rejection is very important. About 18% of the organ kidney transplants are done through the living donor sort of the program in the United States. So when you have living donors, many living donors are, blood unrelated donors, right? They're not blood related. So there's a high risk of rejection. So how do you optimize this? And by this kidney pair donation program, it's a really important problem to number one, reduce the rejection of and secondly, increase the number of the transplants, right? In the transplant. So Jack Hofflish and I have been working together to develop some integer optimization algorithm to really do this in a large scale allocation programs in here. Some hospitals are using our software to make initial decisions how to, match the organs, which I think is quite a high impact in terms of life saving. I feel that this, as a statistician, if you can deliver something like that, that's really worth our whole effort in our education and so on. That's really something I've been enjoying doing a lot.
Thank you, Peter.
You talked about this in my talk, so I think I would actually, if I mean, it's just one example, but I think the work I did on modern slavery is an example where, it was an interesting problem, but I hadn't really realized how much influence it would have. But there are funny stories about it as well. I remember going to a meeting with the police. There was a senior policeman there, and they said, well, we know that there are 13,000 victims of modern slavery in this country because Professor Silverman did this work, which showed that. And I put my hand up. I said, well, actually, that's who I am. And I don't know if I believe that number, so you shouldn't take it too seriously. So it's quite amusing when your work has even more impact than it deserves. But anyway, that's it. But I think that to capture the public imagination in that way was quite important.
Yeah, thank you both. So your research has good impact to public health and government. So when you do a collaboration, for example, to make this work, what challenges have you faced when trying to turn the research finding to real-world policies or actions? And also what lessons you have learned?
I think the challenge is sometimes to persuade people that it's actually to explain to people what you're doing and why it matters. So another example we had when I was in government was that they were very keen on methods of finding out if someone turns up in the country and you don't know how old they are. It's very important that you should try and estimate their age, especially if they're 16, 17, 18, 19, because adults are treated differently from children in this respect. And we had someone who came to us in the government who said that you could do it all by looking at people's teeth. And I looked at the original data, I talked to the person, I did other analysis, and I came to the conclusion that you couldn't, that it was not really reliable at all. But it was quite difficult. It's reliable on a population level, but for any individual, the standard error, the estimation is so wide that you can't actually use it to tell how old people are. When I talk to people about it, I used to sit down and I say, right, before we do anything else, how old do you think I am? And for various reasons, they always underestimate my age. I think I'm much younger than I really am. And I said, well, there you are, you see. So you can't really tell. Very difficult. So the difficulty was to explain why it was not a good idea to somebody whose job depended on showing it was a good idea. And I wrote this very tactful 10, 15-page paper about it, and it didn't go anywhere. They were going to understand. And then my assistant said, you have to be much more assertive. You have to say, if you try to do this, I will stand up and say you're wrong. I'll do it in a way that will embarrass you. And only then did they kind of lay off and stop trying to do it this way. Very interesting. So I think that was a challenge. So I think that the lesson is do not try and get to people where they are. Try and don't, they will know about different things from you. Explain clearly and simply and politely what you have to offer. And don't try and egg it up. Don't try and make it too exciting, but try and make sure, because communicating your results is just as important as finding them. You don't communicate them. I remember Manny Parson once said to me, if you have a really good idea, you have to sell it. Well, that's the way he worked. He was a wonderful man, lovely man. But I think that you know, somehow, especially when collaborating, especially when trying to influence policy, finding the right way of communication is really important.
I think there are many challenges when you engage the collaboration work or your own research and so on. One, I just named two. In terms of collaboration, I think communication is extremely important. You need to understand the actual problem, because as a biostatistician, we always one of our sort of the task is to formulate a applied problem to a statistical problem. You have to formulate the problem in the right way so that you can identify right method, software, or even the resources to solve the problem, right? I think that communication plays a very central role in, um, you know, creating an effective collaborative mechanism between you and your collaborator. Of course, some problems are harder, some problems are easier, and some problems, are more impactful, some, problems less. And some collaborators are doing more cutting edge research. You have to use your judgment through those communication, and then to have the right judgment. This is really important for junior faculty, right? So, for example, I found that, right? So, the NIH grants have the pay line. If you work with very strong researchers, the pay line is more than 50% percent. If you work with, other research, maybe you only get the average or you lower than average sort of pay line. So I'm thinking that if you're able to communicate with the collaborators and understand the research impact and the importance, and then you can help them to really deliver something even stronger using the statistics method. And that certainly is a huge plus. The second thing I think is time management. Like, we work on a lot of our own research problems, but in the same time, we have to get involved those very, very tedious applied problems, and you got to love those collaborations. You got to love doing applied work, but same time it's very time consuming, and sometimes those collaborative projects may not innovate some interesting statistical problems that you have to learn how to manage your time, allocate your resources to do that. But one thing I learned from my collaboration, I think it's quite an interesting thing. I just learned in the recent year is the pattern. Like, statisticians never thought about to pattern their sort of the work. I didn't do it in my first 30 years of my career, but until I start to work with an engineer professor in engineering school here at University of Michigan. He basically patterned everything he did, almost everything, nearly everything he did. I mean, algorithm, everything. I was like, I didn't know this. And then, it's good. You never know, right? Some of your algorithm or ideas or something can be have a broader impact, and some industry, a business can really start to your stuff. Then why not just put your fingerprints on that, and when people use it, they pay for your work, right? In some sense. So I think that's something probably all the people could consider. I mean, if you haven't done that. For me, I think that's something I learned from my collaboration, which is good. Yeah.
Yeah, thank you both. I heard communications and the time management are two challenges. And thank you, Peter, for raising the pattern application. Yeah, that's a wonderful suggestion. Another question I have is how do you build a strong teams? We realize we know that when we want to do collaborations or make a bigger impact, usually we need teams with diverse backgrounds and different people. So my question is that how do you build those strong teams, especially when you need people from different fields?
Actually, sure. Should we answer? It's a good question, but do you think we should answer the question in the chat? Because we may run out of time. That's all I'm concerned about. So that's an interesting question. But I'll talk about teams. I don't know anything about teams. I mean, I don't feel I was ever very good at this. But I'll when you do media training, they tell you don't answer the question that was asked, answer the question you want to answer. So I'll move the question along a bit. I think involving your colleagues in what you're doing is very important as well. So if you have a good student, take them along, introduce them to the people you're talking to. Be generous with your ideas with them and so on, because then they will themselves help you with the work and do their own thing as well. So I think that's a way of building a strong team is for the people in the team to get something from it, is the way I would see it. That's that. But the difficulty is that, and I've always rather worked on my own, I suppose, in collaboration, is that if you're not careful, you just get sucked into the business of having to write very complicated grant proposals that have everybody in them and so on. And if you want to know why I gave up being an ordinary academic, you're beginning to get there, because I got fed up with doing this sort of thing. But I think that involving, you need to involve people in what we're doing. Actually, if I may, I'll go back to the previous question you didn't ask, which was about statistical leadership, which is the same thing, really. And the question was, can I think of a time when statistical leadership changed your perspective? And I think I've had some role models who really gave me a perspective into be a statistical leader. And one of them, Peter's already mentioned, was David Cox, who was a great friend of mine, really, and who lived very near me in Oxford here. And I saw him when he was 95, and he was on his way into work. It's quite remarkable. But he was someone who would contribute to discussions on almost any topic. And so he was able to intuitively see ways of handling issues in almost any subject you can mention. And I think he had a very nice, modest approach to life, which I think had a lot to did a lot to benefit people. Anyway.
Thank you, Sir Bernard. Yeah. Peter, you want to say something?
I can, yeah. From my perspective, I think the basis to build a strong team would start with good problems. If you want to attract good people to come to work with you, you got to have kind of exciting research programs, good problems. If they spend 2 or 3 years, 5 years with you, they will end up with something, good work, good publication, good career, right? So I think that if you could start with some good science, good problems, you basically have, I think, 50% of the chance to build a strong team. Then next thing is that you need to know the big picture, what the strengths that you need or skills you need to do that, right? So I think the team building is time varying. It really depends on what things you're trying to do. Like before, if you want to solve GRM versus now you want to solve neural network, certainly the skills are very different. You really need to know what the strengths that you need to deal with those programs and the research problems. And then when the individuals who are recruited to your lab or your team, you should know that what are their weaknesses as well, right? So that you will help to build them to overcome their weakness, and so sometimes that people are very confident about their their skills, but sometimes it's good to point out that, hey, you need probably a little bit extra work here, there, and so that is very important part of the being a leader. Individual strengths and weaknesses, and when I try to look at individual, I think motivation is extremely important. People who are so motivated to make a big impact or to do good research, uh, basically will have a good motivation. You can see the great progress, right? So you sometimes you do encounter a situation that some trainees or your coworkers are not making great progress. It's very frustrating. So I don't know. I mean, this could due to multiple factors, but I think motivation is extremely a driving factor for people to really move forward because they have curiosity. They want to see what's going what's the ending of this story. So they're motivated to solve the problem, and they more motivated to work with me or other team members to make progress. I think that is quite important things I look at when I try to recruit someone to my team to work with me. Yeah.
Thank you, Peter. I just checked the webinar chat. Zhang Lu had a nice question. What statistical methodology should current students study in order to prepare for working on real-world problems?
Shall we go? Thank you, John. This is an interesting question. A lot of real-world problems are very simple, so I think it's quite tricky because you can't. In a way, you want students to know not everything, a little bit about everything, so that if a new method comes along that they need to use, they will be able to learn it. So they have to have the foundation to be able to go right across the field and then learn about new things if they need to. So I think there has been a bit of a temptation in the machine learning and so on world to use things like machine learning when in fact there's a simple answer. You can actually estimate it. You don't need to use some complicated method. And also it's the perfect and the good issue. So I think the perfect being the enemy of the good, you're looking for the optimal way of doing something when actually something quite simple does. So I think what I would like people to know is really the stuff that John Tucker used to go on about. Simple graphical presentations often tell you everything. Educate your intuition so that when you look at some numbers or something, you can see the pattern that's there anyway, and then you might use a method to get into it in more detail. Obviously, all the modern computing, all the modern methods that are around, but I'm amazed how people, even things like drawing simple graphs, seems to be beyond a lot of people because they think it's too simple. I've also found that I've used simple operational research stuff, a bit of queuing theory, a bit of linear programming. Those are the sorts of things that there are many real problems that are actually important there. Peter talked about the kidney example. That's an example of a multifactorial optimization. We haven't talked about it, but I can see immediately that you've got many different inputs and you're balancing costs and benefits and optimization and a bit of dynamic programming and so on and so on. So I think the more different things that people know about, the bigger the toolboxes that they have that they can then draw on, because the risk is that people have a very narrow view and then they're always trying to find the answer to the question to fit their answer, which is not always what you need to do.
Thank you, Silver.
So,
Peter.
sure. From the sort of big picture point of view, I think in the past 6 decades or so, statistics started to have this very interesting journey of computational statistics, starting from EM algorithm and followed by the MCMC, and then back propagation, then lasso, then the neural network, right? So I think that the statistic, I think it's I think there's probably consequences of integrating more and more of these applied problems because we need solid, well integrated numerical tools with statistical principles and processing data. So you can see that, right? EM algorithm, MCMC, back propagation, and the lasso. Those are really the numerical recipes that solving real world problems. But if you ask me what are the really promising statistical methods, I think that I can say that there's a need to have some innovation in the causal inference. I think causal inference is really important. It's beyond inference. I think that that's very important in both machine learning and statistics. But those fundamental assumptions like are not checkable, right? So you know that. So that how do you just have a human being and we're practicing statistics talking to medical doctors where the causal inference cannot be easily achieved unless you do randomized trial. And how do you sort of do this in a more applied way, or I don't know, like how those things can be really put in the very applied context. I think there's huge challenge, and yeah, I think that the also you how we are going to use this large language model, deep learning, which are good for prediction. So I think there's a trend about this prediction empowered inference. I think that's a good direction. How do you possibly use predict synthetic data to enrich your data and to really come up with something better than just using the data itself? I think there's some interesting, important problems that we could bring into the literature and to see the signature contribution for statistics. And I think the problems that I think that in my view are probably quite important to study at this moment.
Thank you, Peter. So Kiefer has a question here for the sake of time. So maybe we just say that's the last question. So how can we train our graduate students in statistics and biostatistics to remain competitive amid the growing influence of data science and the related fields?
Well, we are the related field. That's the point. So we have to actually, it's no good pretending it's not there. And I think statistics has a bad record of losing the plot, that we're a bit too purist in the way we think. And so we allow other people. So I think we've got to join them. We've got to become part of it. And because you'll discover that data science is just statistics. It's not any different. And so I think we need to actually also understand that they do bring things from the computer science world and things like that. So we should celebrate the rise of data science. We shouldn't. Finally, people have understood that what we do is worthwhile, and but we shouldn't be too picky and too worried if we think they're not doing things quite right. So we train them by making sure they understand what's going on in these areas.
So we had a retreat at the University of Michigan that involved about 30 biostatisticians last year in May. And I think there are about 10 department chairs and that retreat. So that retreat is exactly talking about the question that you just raised, how we're going to modify our curriculum training for our students so they can be competitive and have a good market values. I think we're writing the white paper at this moment. It's going to be ready to be circulated in the community in a couple of months. So there are a lot of things that people discussed during the retreat, a 3-day retreat, and so I think that could be a beginning of delivering the answer to your question. But one thing I feel as extremely important is like how we are going to integrate our curriculum training with industry, because we invite also the industry speaker coming over to part of the participate in the retreat. And one suggestion is that maybe our dissertation committee can have one external reviewer from industry. So we send a lot of our graduates to industry across all different disciplines. They have tremendous sort of the insight, what are actually need in industry and what are important problems they are trying to solve. Of course, there's a confidentiality issue about their business, but they can lift up some of the problems, make them like statistical problems to us to solve. Because a lot of time we just read the paper to figure out the problems, but that having the feedback, some information from the people, our own graduates who work in the industry, who have training in statistical stuff, can really facilitate the communication and for us to identify important problems for our students to solve, and even teaching our courses, and so that student can be better prepared for a job or for either compete with the sales people and so on. So I think we have our unique strengths in many ways to really make good contributions to data science. Yeah.
Yeah, thank you both for the very insightful comments. For the sake of time, let's call it the end of the webinar. So this webinar is recorded, and it will be posted to the YouTube channel and make it public available and to everyone. So thank you very much for listening. If you find this conversation to be helpful, please stay tuned and share the recording with your friends and colleagues. I want to finally especially thank you behind the scenes, Lauren Crawford, Jessica Lee, Amita Manatonga, and Megan Glean, who supported this webinar. Well, in the future, stay tuned for more events like this from the COPSS-NISS Leadership Webinar Series. And that's it. That's all. And thank you. I wish you all have a great summer break. Thank you and bye.
Thank you.